was to do the conversion as a prerequisite to the unit circle. So if you take a second and look at the answers to these questions in terms of the conversions. So we have going across 0, pi over 6, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6, pi, 7 pi over 6, 5 pi over 4, 4 pi over 3, 3 pi over 2, 5 pi over 3, 7 pi over 4, 11 pi over 6, and 2 pi. These are going to be the important angles on the what's called the unit circle. So let's take a look. Okay, so here is your unit circle. Basically what the unit circle is, it is a circle, obviously, on the coordinate plane where you have your x-axis and your y-axis defined. So here's your y-axis and your x-axis, where the radius of the circle is equal to 1. What that means is that from every point on the center to a point on the circle is 1 unit. Okay, so if I look at this ordered pair, it is the ordered pair of 1, 0. If I look at this ordered pair, it is the ordered pair of 0, 1. Over here I have -1, 0, and I have 0, -1. Those are my quadrantal angles. The quadrantal angles are 0 degrees, 90 degrees, 180 degrees, and 270 degrees. Because they are not in a quadrant, sorry, this is also 360 degrees. They're not in a quadrant, they are on the axes. Okay? The equivalent in radians, so because we're working with trig, we have to know both the degree measurement and the radian measurement. We just did those conversions up on this previous page. So 0 degrees is 0, 90 is pi over 2. I'm going to do these in pink. 180 is pi. 360 is 2 pi, and there was one more, 270 is 3 pi over 2. Those are my quadrantal angles. So if I go back down here, I'm going to label these. This is 0 radians. This is also 2 pi radians, because one full rotation around the circle, remember circumference is 2 pi r, 2 pi radians. Okay, this is pi over 2. Here is pi, and this is 3 pi over 2. Okay, so those are our quadrantal angles. The ordered pairs are x and y. Okay, so this is every ordered pair is x, comma y, which is the distance from the center of the circle. Okay, now let's look at the other 12 angles. So the first I'm going to do is 30 degrees. This is 30 degrees. And then I'm also going to do 60 because that I'm going to count in increments of 30. 30, 60, 90. Then comes 120, 150, 180. Then 210, 240, 270, and then 300, 330, and then 360 degrees. We'll take a look at the relationships of the 30, 60s, so on, the increments of 30. The increments of 30 either have a denominator of a 6 or a denominator of a 3. And it's basically counting in fractional form. Okay, so I'm going to do those here. These are the ones that are all increments of 30 degrees. those, and this one. Okay. So notice how the first one, 30 degrees, starts with pi over 6. So when I go down here, this is pi over 6. Pi over 6, then the next one would be 2 pi over 6. This is 1 pi over 6, 2 pi over 6. Well, 2 pi over 6 reduces to pi over 3. And then 3 pi over 6. Well, 3 pi over 6 reduces to pi over 2. So then 4 pi over 6. That's 2/3 pi. 5 pi over 6 doesn't reduce, so this is 5 pi over 6. Sorry, get that right with that. And then 6 pi over 6 is just pi, because they cancel out, right? 6 pi over 6 is just pi, because the 6's cancel. All right? So that's what's happening with all of our reduced fractions. All right, let's keep going, counting by pi's over 6. So 7 pi over 6 doesn't reduce. 8 pi over 6 does, to 4 pi over 3. 9 pi over 6 reduces to 3 over 2. 10 pi over 6 reduces to 5 over 3. And, let's see, I just did 10, so 11 pi over 6 reduces to 3, doesn't reduce, sorry. And then 12 pi over 6 is just 2 pi, because 12 over 6 is 2. Okay, so those are your corresponding angles of the 30s. Well, we have talked about what happens with a 30-degree angle before, right? Where I have a triangle, I can create all these little triangles at 30 degrees. If this is 1, then we know that this is the hypotenuse, the 60 is right here. The distance between the 60 degree and the 90 degree angle is half of the hypotenuse. And so if I do 1/2 squared plus whatever the y value is squared, I'm going to get 1 squared. Well, that becomes 1/4 plus y squared is equal to 1. So y squared is equal to, subtract that, we get 3/4. And if I take the square root, I get y equals the square root of 3 over 2. So this is the square root of 3 over 2. Well, this value is the y value, the y value, and this value is the x value because it's the number of units over, which means that this ordered pair is going to be the square root of 3 over 2, and the y value is a height of 1/2. Okay, that's the ordered pair. Let's talk about we'll talk about in a second how that relates to trig. Okay, so then we're going to do the 60 degree. Well, the 60 is just a rotated version, where now I have the 60 down here at the bottom and the 30 is up here at the top. So between the 60 and 90, and this is a hypotenuse of 1, so between the 60 and 90 I have 1/2, and then between the 30 and the 90 I have the square root 3 over 2. I just reverse it. So now this is my x and this is my y. So I'm going to put a positive 1/2 and a square root 3 over 2. So notice how these two ordered pairs just switched places. Okay, so when I get over into this quadrant, quadrant 2, notice how this point and this point, they're the exact same height. They're also the same distance from the the origin. The x distance is the same because we could essentially create a reciprocal triangle. So if I draw in a reflected triangle, here's my triangle. I'm going to draw this in. So if I draw in that triangle and I draw in the same triangle over here, It's a mirror image. Well, the only thing that's changed is I'm in a negative quadrant for the x value. So I'm going to say that this is a negative 1/2. I'm changing my x value to be negative, but the height is still the same at square root 3/2. Well, the same thing is going to happen with my 30 degree, because the 30 degree, if I look at this point and this point, they're the same height. The difference is I'm reflected into a different quadrant. So this is negative root 3/2 and a positive 1/2. Well, now in the third quadrant, look what happens. This point, let's change colors. This point and this point, they're the same x distance, so they're both negative root 3/2. But the y distances, they're the same, but one is below the axis, so that becomes a negative 1/2. I still actually want that to be blue. Okay, then if I look at this value, it's the same as this top one. So we're going to just change. This is a negative 1/2, and this is a negative root 3/2. Notice how the ordered pairs are switched between the two different measurements or increments of 30 degrees. And then when I come into quadrant 4, I have the same y value here, so negative 3/2, and then I have the same x value, but it's going to be positive because now I'm in quadrant 4 and x is positive in quadrant 4. Then for this one, hopefully you notice the pattern, switch them, so square root 3/2 and make it 1/2, but the y value is negative. Okay, so notice how in this quadrant we have positive, positive. Sorry, my eraser. Positive, positive. This is negative, positive. This is negative, negative. And down here we have positive, negative. Okay. Now we have the 45-degree angle. That's the one that's in the middle. Okay. So this is my 45 degree. I didn't actually have a conversion for that one, but it's pi/4 because it is 1/4 of the circle. If this is 90, then halfway is 45. Or if this is pi/2, half of a half is a fourth. Okay? Over here, so let's count by increments of 45. 45, 90, 135. Then I have 180, then 225, and then 270, and then 315, and then 360. If I look at the three remaining conversions, I have 3/4 pi, 5/4 pi, 7/4 pi. So this is 3 pi/4. I have 5 pi/4. And 7 pi/4 for our radian measures. So then let's talk about what are the ordered pairs. Well, because these are 45-degree angles coming from the center, so there's my triangle, I'm going to have a 45, 45, 90 triangle. If this is 1, remember it's x and x. So x squared, because they're the same length, x squared plus x squared equals 1 squared. That's 2x squared is equal to 1. Divide by 2. And so we get x squared is equal to 1/2. If I take the square root of both, I get 1 over the square root of 2. I can't have a square root in the denominator, so I rationalize it, and I get the square root of 2/2. Square root of 2/2 is each of the x values. So this is the square root of 2 over 2, and this is the square root of 2 over 2. That's my x, and that's my y. So if I go to my ordered pairs, this is the square root of 2 over 2. And this is the square root of 2 over 2. They're the same because they have to be the same distance vertically and horizontally. Okay? If I look at quadrant 2, it's the same distance and height. I just changed my signs. In quadrant 3, I change. Both signs have to be negative. In quadrant 4, x is positive and y is negative. Okay, so that's the unit circle. So now the question is, how does that relate to trig? So if we look at, no, I'm going to ignore that for a second, sorry. If we look at what we've been doing before, and I've asked you to cover the sine of 30 degrees. Well, the sine of 30 degrees is equal to the opposite over the hypotenuse. So if I look at this triangle over here, the sine of 30, the opposite is 1/2, the hypotenuse is 1. 1/2 divided by 1 is just 1/2. If I ask you to look at the sine of 60, the sine of 60 is equal to the root 3 over 2 over 1, which is just equal to the square root of 3 over 2. Both times, both times, if I look at the sine of 30, where do I see 1/2? It's the y coordinate. Where do I see the sine of 60? Square root of 3 over 2. It's the y coordinate, which means that the sine of any angle, and this is the big idea for trig. I know I have a lot going on here. The sine of any angle is always equal to y. Okay, that's a big idea, and that's really important because now we can use the unit circle and just refer to the unit circle. If I ask you the sine of 135, I go to 135, I tell you the y coordinate. It's the square root 2 over 2. There's your answer. You don't have to use right triangles anymore. If I ask you the sine of 240, I go down here to 240, I look at the y coordinate, it's the negative square root 3 over 2. Okay, and so what happens is the same thing happens with x. So if I asked you the cosine of 30, so over here, the cosine of 30 is the adjacent over the hypotenuse. Well, the adjacent is the square root of 3 over 2. Over the hypotenuse is always 1. That's just equal to the square root of 3 over 2. If I look at 30 degrees, there's the square root 3 over 2. If I asked you for the cosine of 60 degrees, cosine 60 is the adjacent over the hypotenuse. That's 1/2 over 1, which is 1/2. It's the x value of the ordered pair. So not only is the sine theta equal to y, the cosine theta is equal to x. And that is the big idea about trig. Okay? And we can use the unit circle to help us find those sine and cosine values quickly and easily.